We're going to spend the next couple lessons going over different factoring techniques. Again, we're going to be starting with the greatest common factor and factor by grouping, which lays the foundation for a couple other methods that we're doing. So looking for a greatest common factor is always going to be the first step when factoring any polynomial. So we want to examine all terms and see if they can be divided by the same expression. So looking here at 8 and 12, we can look at the factors of each of these in a more formal setting. We have factors of 1 and 8 and 2 and 4 to give us 8, and we have factors of 1 and 12, 2 and 6, and 3 and 4. The largest number that's in both of these lists is the number 4, meaning it's the greatest common factor among these two values. So we can basically use our distributive property to factor out the common factor of 4, leaving us with 2x plus 3. Now you don't need to do this form of a process with every step, but this helps to visualize the process behind the mathematics that are happening when we do factoring. So we identified our GCF and we factored it out, leaving us with the quotients when we divide both by the GCF. So when we look at 56 and 35, they have a GCF of 7, and so we can go ahead and we can factor out a 7. 56 divided by 7 gives us 8m, and then 35 divided by 7 gives us 5p. GCF here is 12, so we factor that out. 12 divided by 12 is 1. 24 divided by 12 is 2. GCF here is 3x squared. Factored out leaves us with 3 plus 4x. We could add more terms. The numerical GCF between 24, 18, and 6 is 6. Then we're looking at the m's. It's going to be the lowest exponent among all of the variable m squared. And then we're looking at all the variables n, and it's going to be the lowest exponent of n to the first. So we factor out 6m squared n. 24 divided by our GCF is going to be 4mn. 18 divided by our GCF leaves us with 3. And the 6 divided by our GCF leaves us with m squared n squared. The GCF doesn't have to be a monomial. It could also be a binomial or trinomial. Here we have a common factor of x minus 5 within these two terms. So we can factor out x minus 5, leaving us with x plus 6 plus 2x plus 5. Combine like terms, and we're fully factored. Here again we have binomials, but we have r plus 2s squared as our greatest common factor. So when we factor it out, we're left with p minus q r plus 2s, and then we can distribute to simplify. Lastly, we could factor out a negative, a, leaving us with a squared minus 3a plus 5, which can also be factored with a positive a instead, leaving us with negative a squared plus 3a minus 5. Either one of those is equivalent.